All right, ladies and gentlemen, we're looking at 2.5, reasoning with properties from algebra. These properties, I would get out your postulates and theorem sheet, and you can write these properties down on it as well. Okay? Remember, you can use all these in your quiz on Friday, so you're going to want them. Okay, addition property just means A plus C equals B plus C if A and B are equal. Subtraction property. A and B are equal, then A minus C is the same thing as B minus C. Multiplication property. If A equals B, then A times C equals B times C. Division. If A and B are equal, A divided by C equals B divided by C. Now, all of those you've seen before, I'm sure. Addition, subtraction, multiplication, division. Now we're getting into some that look different. Reflexive property. A equals A. Okay. Symmetric property is slightly different. A lot of people get these mixed up. You see how reflexive says A equals A? It's the same thing on both sides of the equal sign? Okay, symmetric, if A equals B, then B equals A. We flip them. They're different on each side of the equal sign, but no matter which side they're on, still the same thing. Transitive property is very similar to syllogism. If A equals B and B equals C, then A equals C. Okay? If it is the largest of all birds, then it is an ostrich. If it is an ostrich, then it's flightless. If it's the largest of all birds, then it's flightless. That's the same thing as transitive. Substitution. If A equals B, then A can be substituted for B. If I'm not here, who's here? Substitute. You take it out, you put something else in. If they're equal to each other, you can substitute it. Not that a substitute's equal to me, right? Remember, I'm in charge of grade. You laugh at my jokes. It's the rules. Okay. That was a joke too, guys. Whatever. All right. So what we're going to do for example 1 is we've got an equation that we have to solve, but we have to state each step that we're doing what we're going to call it. Is everybody with me so far? Okay. So for A, my original problem, 10 minus 2x equals 3 times x minus 2 plus 4. Okay? So right here are the steps. On the other side is the ribbon. Is the reasons. Excuse me. And this we call, and we'll talk about this more with more of these, but the first one's called the given. We're given that information. Does that make sense why it's called given? I give you the information. Nod your heads. You're awake. Okay. Who wants to tell me what is the first step for A? What am I going to do first? Yes, Derek, raise his hand.
We're just going to multiply.
Yeah, multiply that 3. We call that the distributive property. So I get 10 minus 2x equals 3x minus 6 plus 4. And right next to it, what did you guys call it again? Distribute. I'm going to take a spelling class one of these days. Distributive property. Okay. Now I should do what? Combine like terms. 10 minus 2x equals 3x minus 2. And we simply call this combining like terms. Okay. What should I do next? Anybody? So we're going to move what to what?
We're going to move the negative 2.
We're going to, and that's called what? Instead of minusing it, we're going to add it. So this is just the addition property. What am I going to do next? Add 2. So I'm going to get, and I again just added. finally, we're gonna divide. And we call that division. Do you guys usually have 12 over 5 equals x, or what do you guys usually have? What comes first? X equals 12 over 5. What will we call that when we can move it around? So look at those properties at the top. This is a new one. What one do you think it is? Symmetric. Yes. I added 2 to both sides. So right here, it says addition. I added 2. Is that better? Okay. All right. I'm going to have you guys do B on your own. If you don't have enough room, you can do it up in empty space up in vocabulary. But I'm going to give you a minute. I want you to try to do B all by yourself. All right, ladies and gentlemen, let's try B together. Okay, so the first thing is we've got 2x plus 3 equals 7x, and that's our given. So our first step should be to do what? Yes, Quentin? Subtract 2x.
Oh, you got it.
Yeah. Okay, next step. Divide by 5, thank you. So I've got 3/5 equals x because I divided. And finally, if I want to put this in different order, Jacob?
Flip it, symmetric.
Flip it, and we call that symmetric. Nice. Not too bad? Okay, that's it with algebra. Now we're going to do the same thing, but for some geometry stuff. You ready? Okay. In the diagram, we know that W to Y is the same as X to Z. And we want to show that, so we're trying to show, we don't know, that WX and YZ are the same. Okay, so the first thing we do, draw that line down the middle, and we're going to do statements and reasons. Okay, so the information that's given is WY is congruent to XZ given. And I know it says equal to on there, that's a typo on my part. Okay, so let's talk about this. What do we know? What do we know about W to Y? Is it one whole segment, W to Y? There's nothing in there? There's a point in between. So WX and XY makes WY. So if I wrote this down, WX plus XY equals WY, what would that be? What kinds? Those are what? Are those angles? Are those numbers? Those are, so segment addition. Okay. What about XZ? Can we do the same thing? Can we say XY plus YZ equals XZ? And that's segment addition? Yeah? Uh-huh. Okay. Let's think about this. I'm given that WY and XZ are congruent to each other. That's a given. So can I say that WX plus XY equals XY plus YZ? Does that make sense? These two are congruent to each other. Therefore, the ones that add them up are congruent to each other. What do we call that? I took something out and I put something in. Substitution. Okay, this is going to look a little weird, but I want you to just think about it. Is there anything on either side that's the same? XY. So could I subtract XY from both sides and they would cancel? So I'm given WX is congruent to YZ by subtraction. And what were we trying to prove? Exactly that. All right, I'm going to skip B and C for right now, and I'm going to go to D. Going all the way to D. So the first thing I'm going to do for D is I'm going to read this given statement and figure out if that will help me. The measure of RPS. So I still have a hard time figuring out what angle we're talking about. So I'm going to label it RPS. I'm given that RPS is equal to the measure TPV. TPV, so this angle. Which is also equal to TPV is equal to SPT. Oh. And I want to show that if I take RPV multiplied by 3, I get the whole thing. So the first thing you do, you get your statements, and we've got our reasons. First thing I'm going to write down is what? Does anybody remember what we call it? You're given. Good. The measure of angle RPS equals the measure of angle TPV, and TPV, angle TPV, is equal to the measure of angle SPT, and that's my given. Okay. So do we remember that what that's called when we've got, I know the red ones are equal, so RPS is equal to TPV, and TPV is equal to SPT. So can I say that RPS is equal to SPT? Can I say this? What do we call that? When A equals B, B equals C, so A equals C. Transitive. Okay. How many angles do I have here? Do they all add up to be the big angle? What would I call that if the little ones add up to be the big one? And they're angles? Angle addition. So I know the measure of angle RPS plus the measure of angle TPV plus the measure of angle SPT equals the measure of angle RPV. And we call that angle addition.